All right, so 3.6 complex zeros. We're going to be writing polynomial functions given real and complex zeros. So on your preview packet, we practiced with just the real zeros, writing those in factor form. And we're going to use what is called the conjugate zeros theorem to help us write these polynomial functions. Okay, so if a polynomial has a real coefficient, so that means not imaginary, and if the complex number, they call complex numbers Z, so I know that's something new for you. If the complex number is a zero of P, then its complex conjugate, which they call Z with a line over it, is also a zero of P. So you don't have to worry too much about the notation there. Okay, I just want you to understand when you see these blue boxes in your textbook what they're trying to tell you. So this is on page 274, the conjugate zeros theorem. Okay, so if it has a real coefficient, so it has a real number coefficient, okay, the complex value of Z, okay, Z is just what they are calling an A plus BI expression, okay, they're just calling it Z. And then the complex conjugate, they call the Z with the line over it, okay, that is A minus BI. Okay, so you have a complex number and then you have its complex conjugate. Okay, so if that is a zero, then the complex conjugate is also a zero. If A plus BI is a zero, A minus BI is also a zero. All right, so what that means is if 2i is a zero of the polynomial, then negative 2i is also a zero. If 1 minus 3i is a zero, then 1 plus 3i is a zero. Okay, which means all complex zeros come in what? Pairs. Yay. So let's think about why that is. Remember what I represents? What is I equal to? Yeah, the square root of negative 1. Now think about when you are solving and you have a radical. When you're solving and you have a radical, what goes in front of the radical? Plus or minus. Okay, so complex numbers occur with a negative under the radical. When we take a square root, our solution contains plus or minus thus creating a pair of complex conjugates. You guys like that semicolon usage today? Because like really, don't you rarely use a semicolon? This is a good use of a semicolon. Two ideas related. They could be two separate sentences or you can put them together. Okay, so complex numbers occur with a negative under the radical. When we take a square root, our solution contains plus or minus, thus creating a pair of complex conjugates. What's an English teacher always an English teacher? Look at this transition there. You guys feel just like overall just smarter today? No, you're just annoyed that we're doing cross-curricular activities. Okay, all right. So what other zeros would come in pairs? So besides imaginary numbers, what else comes with a pair? Yeah, square roots, right? Yeah, and you could have irrational values. So whenever you have a square root, or whenever you have an even root.
What about multiplicity?
What do you mean?
Like if you had like two like zeros in the same place, like it's 2 and 2.
Yeah, so if you had like x minus 2 squared, then that would be 1 0 with a multiplicity. Okay, so whenever you have a square root in the 0, okay, you have to have the conjugate. Okay, so if you have the square root of 3, the negative root 3 is also going to be a value. If you have 1 plus root 5, 1 minus root 5. Okay, so whenever you have a radical in your 0, so they're going to give you the zeros. If they give you one of these, you have to infer the other one. So when we're finding a polynomial with integer coefficients, first of all, integer coefficients means you're not going to have what? You're not going to have what? I didn't hear it. Integers are not fractions. Yep. Thank you. Yep. So integer coefficients are positive and negative whole numbers and 0. Okay, so no fractions and no decimals. Okay, so you're going to find a polynomial that satisfies those conditions. Okay, so it says that Q has degree, it has a degree of 3. If the degree is 3, what does that mean about your polynomial? Yep, you have 3 zeros. And in the end, your polynomial will have what? What's the degree means it's your highest coefficient, right? So in the end, the highest coefficient is going to be, or the highest exponent is going to be 3. Okay, so if the degree is 3, the highest exponent is 3. Okay, so the zeros, there should be 3 zeros because it's degree 3. So they gave you negative 2 and they gave you I. What's the third 0 that they didn't give you? Negative I. Okay, so degree 3, so we know there has to be 3 zeros. We are going to write these in factor form. Okay, so when I say factor form, that means you are writing it as x minus c. Okay, so it's calling it q, so we're going to say q of x equals. So if you have x minus negative 2, it's really just x what? Plus 2. Okay, if you have I, it's x minus I. If you have x minus negative I, it's really x plus I. Okay, and then you are going to FOIL to simplify. When you FOIL, what two do you want to multiply together first? The i's, okay? If not, it gets really crazy. Just doesn't look nice. This one is going to turn out nice. Okay, so when you FOIL, you're going to FOIL the conjugates first. All right. So x times x is x squared. And then if they're conjugates, what should happen with the middle terms? Yeah, they should cancel. Okay, it should add up to 0. Okay, so you have x squared. This would be minus ix plus ix. That's going to be 0. And then a negative times a negative is going to be negative I squared. And what do we plug in for that? Negative 1. So when you plug that in, just show me what you're substituting, and then you can jump to there. So anytime you have I squared, you have to plug in negative 1. Okay, and then this is going to drop straight down, so you still have the x plus 2 in front. Now you're going to FOIL these two. Now you guys know I like to feel, right? This is the only time I won't. So when you multiply x squared times x, you get x cubed. Oh, actually I will. 2 times x squared. X times 1, 2 times 1. And then you just want this to be in standard form. Okay, so you have a polynomial in standard form. And that just means you start with the highest exponent and then all of the variables are going down from there. Okay? All right, does that ring a bell from last year? Because you would have done ones like that last year. I think we even did some with brackets. So for part B, P has degree 3. The zeros are 1, 15 minus 6i, and 15 plus 6i. So you have degree 3, and they gave you 3 zeros. So if they give you 3 zeros, you don't have to find any of the other ones. We're just going to set this up. But the difference with this one is that you have binomials here. Okay, so we're going to start with P of x equals. And if you have 1, you write it as x minus 1. And then if you have a binomial, binomials get brackets. Okay, all of our first steps should look the exact same. So what we're going to do is we're going to keep this in factored form, which is x minus. So we're going to do x minus, and then we have 15 minus 6i in parentheses. Okay, so we're writing this in factored form. It's x minus your 0. We're going to do the same thing with the next one. So it's x minus 15 plus 6i. And because it's a binomial, we put it in parentheses. And that also reminds us that we're going to have to do what if there's a negative in front of the parentheses? Yep. Okay, so we are going to, now that we've done the brackets, we're going to distribute the negative. Okay, and I write these little notes on here for you for the first one, so if you get stuck on your homework, that helps you. But this is also a great thing, like if you're reading over your notes to study for a test, like you can read those to yourself, and that helps you understand the process better. Especially when we start putting a bunch of things together, right? So now when we distribute the negative, we have negative 15, and then a negative times a negative is a positive. So I want you to leave it like this for now with the brackets. Okay, and then we're going to do the same thing here. So x minus 15 minus 6i. Okay, so I want you to leave the brackets for now. And then what we're going to do is we are going to regroup. Okay, when you regroup, you're going to notice that the real part, the x minus 15 here, is going to match this, the x minus 15. Okay, so we regroup that so that we can FOIL. So when you FOIL, okay, we're going to think of this as the first term times the first term. Okay, so when you think of it as x minus 15 times x minus 15, we're just going to take this slow for now, and we're going to just write it as x minus 15 squared. We are going to simplify that in a minute. Okay, so x minus 15 times x minus 15 is x minus 15 squared. Now, when we do the middle, what we have here is 6i times x minus 15, and then we have negative 6i times x minus 15. So what happens with those two? They cancel out. Okay, so all we have to do is 6i times negative 6i. 6 times negative 6 is negative 36. I times I is I squared. Okay, and then we can plug in the negative 1 here. And then we can FOIL this out. Now, some of you might want to write it like this so that you remember that you are going to FOIL. Okay, and once we FOIL that out, we won't have the bracket anymore. We'll just have parentheses. So x times x is x squared. What's the inside and the outside terms going to combine to? Yep, negative 30x, good. 15 times 15, 225, and then you're going to add 36 to that. Okay, so make sure that you do the order of operations. You have to do the exponents before you can do any of the adding. And then from here, we're just going to add those together. So 225 plus 30 is 255. 255 plus 6 is 261. Okay, and then our last step is going to be to distribute and then add like terms. And I'm going to show you how I like to line this up, what I think is easier. If you guys like writing it out in a big line, you have that option as well. So the first thing we're going to do is multiply everything here by x. So when you do that, what happens to all of these terms? Yeah, they're just going to go, their exponent is going to go up 1. So 2 is going to go to 3. 1 is going to go to 2. You don't have any, so you're going to have 1x there. Then we're going to distribute negative 1 to everything, and that's nice because everything just becomes the opposite. So if you line these up with your like terms, negative x squared, positive 30x, negative 261. Now you can just add straight down. And then they said this was P, so we'll just call it P of x. And this is going to be your final answer. All right, and then do you guys want to try to set up the one on the back? Okay, so look at the degree, and then we're going to set up the factoring terms. Okay, and then the order that you put them in doesn't matter. So if you had negative 1 minus 2i, then negative 1 plus 2i is also a 0. If root 6 is a 0, then negative root 6 is a 0. Okay, so when you're setting these up, you have x minus -1, and you can put the plus 2i first, or you can put the minus 2i first. It does not matter. And then the x minus -1 plus 2i. So do we remember the negative in front there? So the only thing that's the opposite in the conjugate is that middle term. Okay, so you're going to keep the 1 negative. And then here you have x minus root 6 and you have x plus root 6. And again, it doesn't matter which ones you put first. In fact, do you guys want to do this first because it's going to be quicker? The root times the root. Because when you FOIL this, you're going to have x squared and then minus x root 6 plus x root 6 is going to cancel out. What's negative root 6 times root 6? Great. Okay, and then can you guys distribute and regroup, and I'll give you a minute to do that. Okay, so every time you do this, you should notice that those are the same. Okay, and then when you FOIL, we're going to do x plus 1 squared. 2i minus 2i is 4i squared. You can plug in your -1. Make sure that you FOIL this. Don't write x squared plus 1 squared. Okay, what you're going to have is x squared plus 2x plus 1. A negative times a negative is a positive. And then I'm just dropping that down. So now we're going to distribute. And then let's find our that. For the last one, you can use your calculator. And then when you're distributing, if you have a binomial here, I would distribute x squared to everything first. So x to the 4th, 2x cubed plus 5x squared. Then I would distribute -6 to everything. And then again, just make sure that you line them up. So negative 6x squared should go here. Negative 6 times 2 is negative 12. Negative 30. So how do we do on that one? All right, the grand finale, degree 5. We ready for this? Okay, so t has degree 5. They give you the 0, 5 plus 2 root 2, 4 minus I, and 0. So if 5 plus 2 root 2 is a 0, what else is a 0? 5 minus 2 root 2. 4 minus I means we need 4 plus I. Okay, and then you just have 0. If you have x minus 0, what is that factor? It's just an x. So when you start this, you can put the x at the back, but it's very common to just put it at the front because that's the last thing we'll distribute. And then, is this a binomial? Yeah. Is this a binomial? Yeah. So we're going to have double brackets here. So it's always x minus. Okay, x minus. And again, as I'm setting this up, I'm looking back at my zeros and I'm saying, okay, this is x minus 4 minus I. This is x minus 4 plus I. Right? And it's easy to get overwhelmed because this is an intense equation. So what I do is I'm just going to focus on 2 of them at a time. Okay, and you guys can use your calculator for this one because I think at the end the numbers are going to get kind of larger. Okay, so then we're going to distribute. So we have x minus 5 minus 2 root 2. And we have x minus 5 plus 2 root 2. Now, again, make sure that when you're regrouping, every single time we've done this, these have been the exact same. So that pattern is going to continue. Okay, so we have x minus 5 squared. We know this is going to be a negative because we're always multiplying the conjugate. What's 2 times 2? 4. What's root 2 times root 2? 2. So this is really going to be minus 8. Okay, and again, I write this out because it helps me. If you want to jump to the next step, that is fine. Because it's always the first one squared, it's double negative 5 and negative 5. And then negative 5 squared is 25 minus 8. Okay, and then once you have that simplified, now we're going to simplify the rest. Don't forget about our little buddy x there. I'm just going to drop that right down. All right, and then we're going to FOIL here. So x minus 4 plus I, x minus 4 minus I. Okay, so I want you to try doing this by yourself, okay? All right, so when you do this one here, when you are going to multiply those two together, I like to do this one at a time. So if I distribute the x squared to everything behind it, I'm going to get x to the fourth minus 8x to the third plus 17x squared. Then I'm going to distribute the negative 10x to everything. So that's going to give me negative 10x cubed. Negative 10 times negative 8 is 80, so you have 80x squared. Okay, and then negative 10 times 17, negative 170x. And then my last distribution will be 17. Okay, so 17 times negative 8, what does that get you? Negative 136. Can you just check it for me? Is that what you got? All right, and then we know 17 times 17, 289. Okay, so then you have x to the fourth minus 18x cubed. 17 and 17 is 34, 34 and 80, 114. Remember I said you could use your calculator with this. And you get negative 306. Okay, and what is the very last step for this one? Yep. And if you are multiplying everything by x, what's the only thing that happens? The x goes up. So it's x to the fifth minus 18x to the fourth plus 114 x cubed minus 306x squared plus 289. Thank you. 289x. Thank you. Okay, so for all of your homework questions tonight, it's going to be the same direction where you're going to write a polynomial p of least degree for the given zeros. So when they say write a polynomial p, with the least degree, that's exactly what we did here. Okay, so the least degree is including those conjugates. Okay, so I'm going to give you two of the problems, and then a few of them are going to be from your textbook.